Good morning all. This is Dr. D. Khalandar Basha, working as Associate Professor in the Department of ECE, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today I am going to discuss the addressing modes in 8051 microcontroller and data transfer instructions. The slides are prepared by referring the textbook, the 8051 microcontroller, authored by Kenneth J. Ayala, publication, Singh's Publications. Addressing modes of 8051. The way in which the data sources or destination addresses are specified in the mnemonic that moves that data determines the addressing mode. The 8051 family of microcontrollers allows 6 types of addressing modes for addressing the operands. They are immediate addressing mode, direct addressing mode, register addressing mode, register indirect addressing mode, indexed addressing mode, and implied addressing mode. Now we will see one addressing mode, how to represent the data in the instruction using immediate, direct, register, indirect, indexed, and implied addressing mode. Immediate addressing mode. The addressing mode in which the data operand is a part of the instruction itself is known as immediate addressing mode. The data should be present in the instruction for this addressing mode. The immediate data must be preceded by sign, which is hash operator, before the data. Immediate addressing mode is very fast as the data is in the instruction itself and it can be loaded is given in the instruction itself. So example, move a comma hash 25h. So here the 25h is the immediate data that will be copied into accumulator A. The second example, move R4 comma hash 62h. This instruction will copy the immediate data which is 62h into the R4 register of 8051 microcontroller. Move DPTR hash 4532h. As the DPTR is a 16-bit register, the size of the data which we are going to be passed is 16-bit size. This immediate data 4532h will be loaded into the data pointer which is DPTR. Move A comma hash 0AFH. Now here the immediate data is AFH that will be loaded into accumulator. So whenever we are placing the data with a hash symbol, it indicates the immediate data, and if the immediate data is starting with a alphabet in the hexadecimal, either it may be A, B, C, D, E, F, this one should be preceded with a 0. Later you can have any data here. A0 to A9, B0 to B9, or A0 to AF, A0 to AF, B0 to BF, C0 to CF, D0 to DF, E0 to EF, F0 to FF. For all this data, if the first one is a alphabet, that should be preceded with 0. The next one is direct addressing mode. In the direct addressing mode, the data will be refers to a memory location. The addressing mode in which the effective address of the memory location is written directly in the instruction is called direct addressing mode. In direct addressing mode, the data is in a RAM memory location whose address is known, and this address is given a part of the instruction. So let us consider this is the RAM block. Whatever the data which we want to move, which will have some address AA. I am designating for address. DD is the data. So if you want to copy this memory content to some register or any memory location, this will be referred with the address AA. This it is going to be specified in the instruction. For the address, no special character will be preceded. For example, move R0, 40H. So here 40H refers to a memory location. So in the 40th location, assume this one is a 40H location. In the 40H location, you have some data XYZ. This will be copied into R0 register. So after executing the instruction, the R0 register content is the memory location contents. Assume it is XYZ. Move 56H, A. This instruction will copy the accumulator content into the memory location. So here the source is accumulator. It will have some data MN. This it will be stored into the memory location. The address of this one is 56H. After executing this instruction, the data which is present in the accumulator will be copied into the memory location with the address 56H. Next one is register addressing mode. In this register addressing mode, the register is the source of the operand for an instruction. That is, in the register addressing mode, the source or destination data should be present in any one of the registers from R0 to R7. Coming to the example, move A, R0. So here the source content is R0. This content will be loaded into the accumulator. Move R2, accumulator. Accumulator contents will be copied into R2. Add A, R5. So here this instruction, the source operand is in R5 register. This will be added to the accumulator contents and the result will be stored in accumulator. The next one is a register indirect addressing mode. In this mode, the source or a destination address is given in the register. By using this mode, the internal or external address can be accessed. So the memory which we are going to be refer, either it may be present in the on chip or it may be external to the microcontroller. The R0, R1 registers are used for 8-bit address and the DPTR data pointer is used for 16-bit address. Apart from these three registers, no other registers can be used for this addressing mode. And the symbol, which is @ symbol, will be prefixed for the register, indicating it is a register indirect addressing mode. These register indirect addressing mode are also called as pointer registers. Examples: move A, @R0. This will signify the data is present in the memory location. Assume MM is the memory address, and the register R0 will contain the memory address. So after executing the instruction, the contents of the memory location whose address is specified in R0 register will be copied into accumulator. So here R0 contain MM. Now this will be refers to the memory location MM. The contents in this memory location is XY. This will be copied into accumulator. So after executing the instruction, the data which is present at the memory location MM, that will be copied into the accumulator, which is XY in this example. The second example is move @R1, B. Now here the B register is containing some data XYZ. These contents will be copied into the memory location. Assume the address is where R1 register will hold the address of the memory location, that is a target location. The contents of B register will be copied into this memory location. So this instruction will signify the contents of B register will be copied to the memory location whose address is specified in R1 register. The next one is indexed addressing mode. In the indexed addressing mode, the source memory can be accessed from program memory only. The destination operand is always the register A, which is accumulator. With indexed addressing mode, the effective address of the operand is the sum of a base register and an offset register, which is accumulator. The base register can be either data pointer DPTR or program counter, which is PC, while the offset register is the accumulator. So as per the second statement, the effective address, so we can calculate the effective address is the sum of base register plus offset register. The base register, either it can be a DPTR or PC. This will be added with the offset register, which is accumulator. In indexed addressing mode, only MOVC and jump instruction can be used. Examples: MOVC indicates it is a code byte, A, @ A plus PC. So @ signifies it is a indirect manner for referring to a memory location. So the address is there in the program memory. This is program memory. At some address, let us assume at address will have some instruction 1 that will be fetched into the accumulator by evaluating the value of A plus PC, which is nothing but Two values will be there for referring to the memory location. One is base register, either it can be DPTR or program counter. The second one is offset register, which is accumulator. The second example is MOVC @ A plus DPTR, A. So here the contents of accumulator will be loaded into the program memory whose address is specified by the addition of accumulator and DPTR. In this one, this instruction actually it is not a valid, since program memory is nothing but ROM. For ROM, only read permissions will be there, write permission will not be there. As per indexed addressing mode, this will give a indexed addressing mode, but the data moving into the program memory is not allowed. The last addressing mode is implied addressing mode. In the implied addressing mode, there will be a single operand. These are zero operand. These types of instruction can work on a specific registers only. These type of instruction are also known as a register specific instruction. Example, RLA. Here we don't have any source operand or destination operand. So what this one will specify is rotate RL space A. This is the instruction is RLA. Here rotate the contents of accumulator towards left side. So here the default register which you are going to be refer is accumulator. That will call as implied addressing mode. So these are the various addressing modes present in 8051 microcontroller. The various addressing mode which we have discussed are immediate addressing mode, direct addressing mode, register addressing mode, register indirect addressing mode, indexed addressing mode, implied addressing mode. Now today we will see the next topic, which is instruction set of 8051 microcontroller. The instructions of 8051 microcontroller can be broadly classified under the following categories: data transfer instructions, arithmetic instructions, logical instructions, branch instructions, subroutine instructions, and bit manipulation instructions. Now we will see the first category, which is a data transfer instructions. The data transfer instructions are associated with the transfer of a data between registers or external memory, either it may be a program memory or data memory. The mnemonics associated with data transfer instructions are move, move code byte, move external memory, push the data onto the top of the stack, pop the data from the top of the stack, exchange, exchange digit. These are the instructions which are data transfer instructions. Now we will move to the first instruction, which is move instruction. This keyword or mnemonic of this instruction is MOV, which is for moving the data. The MOV instruction moves the data bytes between two specified operands, that is source and destination. The byte specified by the second operand is copied to the location specified the first operand. So in the syntax of the instruction, after MOV mnemonic, the first operand is destination, the second operand is source always. The source data byte is not affected, and the destination register contents or memory contents we will be overwritten with the source contents. The syntax of the instruction is move destination comma source. Here the source can be an immediate data or a register or memory location, whereas the destination can be a register or memory location. This instruction will copy the source contents into the destination. Few examples we will see. Move the contents of a register Rn to A. This will be accomplished with the instruction like this: move A comma R2. Here the source is R2 register and the destination is accumulator. After executing this instruction, the contents of R2 will be loaded into the accumulator. The next one is move the contents of a register, that is accumulator, to some Rn register. Here n, it will take either 0, 1, 2, 3 till 7. It can be 0 to 7. Move R4 comma A. So this instruction will copy the contents of accumulator into the R4 register of 8051 microcontroller. Next category is move an immediate data, which is 8-bit data type, into the accumulator or register or a memory location. Move A comma 45H. As 45 is preceding with hash, it indicates an immediate data. After executing this instruction, the accumulator will have 45H. Move R6 comma hash 51H. Hash 51 is immediate data. After executing this instruction, R6 register will be written with the value of 51H. Move 30H comma hash 44H. This instruction will copy the immediate data, which is 44H, into the memory location. 30H will be loaded with 44H. So somewhere here we have the memory with the address 30H. Into this the 44 will be loaded. Move at date of R0, comma, hash 0E8. The size of the data is 8-bit size, which is E8. As it is starting with the alphabet, it will be prefixed with 0. After executing this instruction, the memory contents the address which you have specified in R0 register will be loaded with the data which is E8H. Move DPTR, comma, hash 0F5A2H. As the data here, it is a immediate data and it is starting with a alphabet, so it is prefixed with a 0. The DPTR is a 16-bit register. The data, that is F5A2, will be copied into DPTR register. The next example is move DPTR, comma, hash 5467H. The immediate data is 5467H. As it is starting, the immediate data is starting with a numeric, so we are not going to be prefixed with 0. So 5467 is the immediate data which will be copied into the DPTR register. In all these examples, except the DPTR move instructions, the remaining all are 8-bit data transfer. Whereas for DPTR, which is a 16-bit size, so the 16-bit data will be loaded into DPTR. Next, move the contents of memory location to accumulator or accumulator to memory location using direct and indirect addressing mode. Move A, 65H. So here the source is the memory location, address is 65H. The contents of the memory location whose address is specified as 65H, these memory contents will be loaded into the accumulator. Next, move A, at the rate of R0. Here we are referring to a memory location in that manner. R0 will have the address. Whatever the R0 address is specified, the contents which are present here, this will be loaded into accumulator. The next example is move 45H, A. So here 45H is the address of the memory location. So the target is a memory location 45H. Whatever the accumulator content is there, these accumulator contents will be copied into the memory location, which is 45H. Next, move at the rate of R1, A. Here, the address of the memory location we are specifying in R1 register. So R1 register will have the address. Into this memory location, the accumulator contents will be copied. So here the address directly it is not specified in the instruction. Indirectly it is specified. That's why we are using at the rate. The next category is move the contents of memory location to Rn or Rn to memory location using direct addressing mode. Move R3, 65H. So here the source data is 65H, which is a memory location. This memory location contents will be copied into R3H. Next, move 45H, R2. Somewhere here assume this is the address which is 45H. This is destination. The contents of R2 will be copied into the memory location. The next type is move the contents of memory location to another memory location using a direct and indirect addressing mode. The first example is move 47H, 65H. Here the source is the memory location with the address 65H. This is what the source. The destination is 47H. Here the contents of 65H will be loaded into the 47 location. Next example is move 45H, at the rate of R0. Here the source is a memory location whose address is specified in R0 location. These contents are loaded into the location with the address 45H. So this is the source and 45H is the destination. The contents of this address which you are specified in R0, that content will be loaded into 45H location. Next, move the contents of external memory to accumulator or accumulator to an external memory. Whenever you are copying the data to external memory, the move instruction will be suffixed with X. X indicates it is a move the data to the external memory. So move X A comma at the rate of R1. Here the contents of the memory location which is external to 8051, the address of this memory location is loaded into R1 register. The contents of the memory location which is specified in the R1 register, these contents will be loaded into accumulator. Next, move X at the rate of R0 comma accumulator. Here the source is accumulator and the destination is a memory location which is an external memory. The address of this are loaded into R0 register. So the accumulator contents are loaded into the memory location whose address is specified in R0 register. As R0 is prefixed with at the rate indicates it is external memory, indirect specified. The next instruction is move C. The move C instruction, it is for move code data. The move C instruction moves a byte from the code or program memory to the accumulator. For this instruction, always the destination is accumulator. The address of the byte to be fetched is the sum of accumulator and the 16-bit register which may be the data pointer or program counter. The syntax of the instruction, move code byte, that is move C, A comma at the rate of A plus DPTR. So the contents of accumulator will be added to the DPTR. This will use the address of program memory. Whatever the contents are there in that location, program memory address, these contents will be loaded into accumulator. Move C A comma at the rate of A plus PC. So here the contents of accumulator will be added with the program counter which will be refers to the address of the program memory. This address contents will be loaded into the accumulator. Next one is move X instruction which is move external. The move X instruction transfers the data between the accumulator and the external memory. The external memory may be addressed via 16-bit address using DPTR and the address size is 8 bits. In that case, the 8-bit address is loaded into R0 or R1 registers only. When using the 8-bit addressing, the port 2 must contain the higher order byte of the address. The syntax of the instruction is move X destination comma source. The move X instruction that transfer the between accumulator to external memory. Now we will see the syntaxes are few examples. Move X A comma at the rate of RI, where RI can be R0 to R7, any one of the register. So the external memory address is loaded into RI register. These contents are loaded into accumulator. Next, move x a comma at the rate of dptr. So now here the address of this is a 16-bit address which it is going to be loaded into the dptr. The contents of this memory location will be loaded into accumulator. Next, move x at the rate of ri comma accumulator. This is a reverse process. The accumulator contents will be loaded into the external memory whose address is specified in ri register where I can be 0 to 7. Move x at the rate of dptr comma a. The accumulator contents will be loaded into the external memory whose address is specified in the dptr register. See, here we have studied three types of instructions related to move instruction. One is move, another one is move c, another one is move x. The difference is move instruction is related to data which is internal to 8051 microcontroller. Move c, it is related to code or program. The data will be fetched from RAM. Whereas move x is to move the data from the external memory into the accumulator or accumulator to external memory. The next instruction is push instruction. This instruction is used to store the data onto the top of the stack. The push instruction increments the stack pointer and store the value of the specified byte operand at the internal RAM address indirectly referred by the stack pointer. SP stands for stack pointer, which is a 8-bit register which stores the address of the top of the stack. By default, the stack pointer is loaded with 07H. The syntax of this instruction is push direct. So whatever you have specified in the direct, that will be placed onto the top of the stack. So for every push operation, first the stack pointer will be incremented by 1. So that is 08H. Onto the memory location, which is address is 08H, the data will be pushed. The next instruction is pop instruction. This instruction is used to retrieve the data from the stack. The pop instruction reads a byte from the address indirectly specified in the SP register. The value read is stored at the specified address and the stack pointer will be decremented. The stack pointer is a 8-bit register which store the value of the top of the stack, which is address. By default, the stack pointer contains 07H. The syntax of the instruction is pop direct, that is nothing but address. Example, pop 34H. So here the contents of the memory location which is pointed by SP, this will be loaded to the memory location 34H. The next instruction is XCH, which is exchange accumulator with source byte. The exchange instruction loads the accumulator with the byte value of the specified operand while simultaneously storing the previous contents of the accumulator in the specified operand. It is like a swap operation. The source operand can be a register or direct address, or address may be specified in indirect manner through register. The syntax of the instruction is XCH A comma source, the contents of accumulator will be swapped with the contents of source. So after exchange, accumulator contents will be placed in the source operand, the source operand contents will be placed in the accumulator. Example, XCH A comma Rn. So it is the data swap between accumulator and Rn register, where N can be 0 to 0 to 7, any one of the registers from R0 to R7. XCH A comma 34H. Here the contents of accumulator will be swapped with the memory contents, which is 34H. Accumulator contents will be placed into the memory location with the address 34H. The previous 34H location contents will be placed into the accumulator. XCH A comma at the rate of RI. Here the contents of accumulator will be copied into the memory location, swapped with the memory location whose address is specified in RI register, where I can be 0 to 7, that is the registers R0 to R7. So this instruction will do the swap operation. First, the source contents will be placed in some temporary variable. Then the accumulator contents will be loaded into the source operand, and the accumulator will be loaded with the temporary variable. This is what the instruction it is going to do, which is a swap operation. The last instruction under data transfer instruction is XCHD, which is exchange digit. The difference between XCHD and XCH is, in XCH the size of the data is the source and accumulator size, that is 8-bit size, whereas in XCHD only 4 bits will be copied, that is lower nibble of accumulator with the source contents. The XCHD instruction exchange the lower order nibble of the accumulator with the lower order nibble of the specified internal RAM location. The internal RAM is accessed indirectly through R0 and R1 register only. The higher order nibble of each operand is not affected. The syntax of the instruction is XCHD A comma at the rate of RI, where RI can be R0 or R1. XCHD A comma at the rate of R0. So here we are referring to a memory. The memory address is loaded into R0 register. The lower 4 bits of this memory location will be swapped with the accumulator lower 4 bits. How about the upper 4 bits is, there will be no change in the upper 4 bits of accumulator and the upper 4 bits of the memory location, which is referred by R0 register or R1 register. So with this, I'll conclude the data transfer instruction. The various data transfer instructions which we have studied in this class are move instruction. Under move instruction, 3 categories: move, move X and move Z. After that, we have studied push instruction, pop instruction, XCH instruction for exchange, XCHD which is for swapping of lower nibble of accumulator and memory location, which is pointed by R0 or R1. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.